What is up, 7th grade? This is lesson 100, and our objective is how do you estimate square roots? Remember yesterday, or last lesson, we were using square roots to calculate the Pythagorean theorem and to find side lengths of the triangle. And so today, we're going to be working with how you can kind of estimate those kind of on your own without a calculator, because sometimes you need to be able to do that even though you don't have a calculator with you. So let's just remember that a perfect square, what we call a perfect square, is a number whose square root is a whole number. So here, I'll highlight them here in yellow for you. All of these numbers and these numbers are what we call perfect squares. Now this is not all of them, but this is the first 12 of them. So notice that if you were to take the square root of 1, you just get back 1. Or the square root of 4, meaning what times itself gives you 4, well 2 times itself gives you 4. The square root of 9 would give you 3, the square root of 16 would give you 4, etc. So these are the perfect squares, and these keep going, right? But these are just the first few, and you do need to know these, so working committing these to memory, you're going to appreciate it later on. Just the more you practice, the more you'll be able to do. And most of these you should be able to know because you already know your multiplication tables. So it's just like 6 times 6, 7 times 7, 10 times 10, 12 times 12. So let's try one here. It says, estimate the square root of 45. So what we're going to do is, what I'm wanting to find out is the square root of 45. So what I'm going to think of is I'm going to try to think of a perfect square that's bigger than 45 and a perfect square that's smaller than 45. So the first one I think of is 49. And then, because this is 7 squared, the next number down is 36. So that's 6 squared. So notice it kind of makes sense then that if we said the square root of 36 and the square root of 49, we know that the square root of 45 is going to be bigger than the square root of 36, because 45 is a bigger number than 36. And then we also know that the square root of 49 is going to be bigger than the square root of 45 because 49 is bigger than 45. So I picked these because these are perfect squares, okay? And we'll simplify this down in a second. Now, if you just look at these numbers, is 45 closer to 49 or closer to 46? Well, we know it's closer to 49 because it's only 4 apart, whereas this is like 9 apart. So I'm going to know that this is going to be closer to whatever this is. So let's see here. The square root of 36 is 6. This is the square root of 45. That one doesn't simplify down. And the square root of 49 is 7. So we know that this number lies between 6 and 7. And so if we just maybe had to estimate if here's 6 and here's 7, I guess it more to be up here. Okay, it's a really horrible 6. Now, we can actually take this a little bit further. If we want to calculate more, like maybe to the 10th or to the 100th, we can try to get more accurate than between, just between 6 and 7. So let's just guesstimate a number between 6 and 7. I'm just going to say, I don't know, maybe 6.6. So I'm going to estimate it to be 6.6. Well, if I take 6.6 and square it, I should get something very close to 45. So if I take 6.6 and square it, this is equal to 43.56. Notice that number is smaller than 45. So I'm going to try it. I'm going to go up a little bit. 6.7 squared. Take 6.7 and square it. You get 44.89. Again, still too small. So I'll go 6.8. Square that. Again, I'm just using this on my calculator. And this one I get 46.24. So notice my goal, remember, is to get that 45. This one is too big, and this one's too small. This one's too small as well. But since this is the biggest they can go without going over, I'd go with this one. 6.7. So the square root of 45 is approximately equal to 6.7. And while I can get more accurate, if I want to, I can say, okay, maybe let's go 6.71 or 6.72. Right? And I can figure out which one of those is the closest, etc., etc., etc. And I can just keep being more and more accurate by adding on another number, right? Maybe 3, maybe 7, whatever, adding on numbers past that decimal place. And the more I do that, the more accurate my answer is going to be. However, if I kept doing that for forever, for the rest of my life, I would still not get a number that's exactly equal to 45. I get something that was really, really close, like 44.999999999, right? I get something really, really close to that, which in most cases would be fine to be accurate enough, but it would not be actually exact. Kind of like pi, right? It's a digit that goes on forever, and you can get, more and more close to pi, but doesn't actually ever equal pi exactly. And that's because we call those numbers irrational numbers. Irrational numbers, meaning you cannot write them, right? Not rational. Rational means you can write them as a fraction. So these you cannot write as a fraction. And then just real numbers is the group that includes irrational numbers, rational numbers, whole numbers, integers, natural numbers. Okay, so that's kind of like the big group that holds all of them that we've studied so far. And irrational numbers are numbers like square root of 45, pi, the square root of 12, the square root of 3, things that aren't perfect squares. That's where they fall into because you can't write them as a fraction. Alright, let's try one more here. It says graph the following numbers at their approximate location. So some of these aren't too bad because we already know. Here's a -1/2. That's going to be between 0 and -1. So I'm just going to put a dot right here halfway in between. -1/2. 2.3 repeating is 2 1/3, or like 2.3, so it's going to be about 1/3 of the way here. 2.3 repeating, so it takes care of this one and this one. Square root of 2 I'm going to have to work with just a little bit more here, but pi I know is approximately 3.14, so maybe approximately right here. Right, because it does say, and it's approximate location, it doesn't have to be exact. So I got those 3. Now let's just talk about the square root of 2. We'll do the same thing we did before. Perfect square smaller than 2 is going to be 1. And a perfect square bigger than 2 is 4. So that means I know the square root of 2 is smaller than 2 but bigger than 1. And I would say 2 is a lot closer to 1 than it is to 4. So I'm going to put it closer to here. Maybe about right there. And I'll say this is the square root of 2. Alright, I think you got the basics that you need to complete this. Your homework is on page 696. You need lesson practice, all the 100s, all the 99s, and 6 more of your choice. Good luck, guys.